So in this section we are studying special right triangles, which helps us find the side lengths of right triangles that have angle measurements of 30, 60, 90 and 45, 45, 90. The first thing I want you to do is to pause this video and to draw out the 45, 45, 90 and the 30, 60, 90 triangles and put in the variables, for example 30, 60, 90. Put x as the short leg and then fill in what you need to do to x in order to find the hypotenuse of the long leg. And then do the same thing with the 45, 45, 90. Put x as a leg and then say how you would get the hypotenuse of that 45, 45, 90. Okay, now on your paper we have this 45, 45, 90 triangle. Now any 45, 45, 90 triangle is an isosceles triangle. So that means that the two legs are going to be equal. So if I wanted to find the value of x, the only thing I would need to do is just state that it equals the same exact measurement as the other leg, which was the square root of 5. In order to find y, I need to take that square root of 5 and multiply it by the square root of 2 in order to find the hypotenuse. In a 45, 45, 90 triangle, the legs are represented by x, and the hypotenuse is represented by x times the square root of 2. When I multiply those two radicals together, I get the square root of 10. There are no factors within the square root of 10 that are perfect squares, so this is my answer for y. My second question deals with a 30, 60, 90 triangle. On this 30, 60, 90 triangle, we know that the opposite of 30, the short leg, is always represented by x, and that the hypotenuse is double x, and that the short leg is whatever x is times the square root of 3. The long leg is x times the square root of 3. So let's say I'm trying to find a and b here. I know that a times the square root of 3 will give me 33. So that's what I'm going to write down on my paper. A times the square root of 3 is what will give me 33. Algebraically, my next step should be to divide by the square root of 3 on both sides. Most of these answers will be in simplest radical form unless otherwise noted. So if that's the case, I cannot have a radical in my denominator, so I need to multiply my numerator and my denominator by the square root of 3. This allows for this denominator to change to the square root of 9, which is also known as 3. I am allowed to reduce this fraction, this 33 over 3, but I will need to leave this square root of 3 here as a radical and not move it. So I get 11 times the square root of 3. So those are problems that when we look at individual triangles, so a 30, 60, 90 or 45, 45, 90, we can solve for the different side lengths. Now let's look at a couple problems that deal with the combination of the two. Here's problem 1. On this problem I have a trapezoid. Two sets of parallel sides, or one set of parallel sides, and I have this, the only angle measurement I've been given is this 45-degree angle. So I need to create a triangle by making a dotted line here from the top base of my trapezoid to the bottom and make it perpendicular and create a 45, 45, 90 triangle. Now what I'm trying to figure out is this value for A, and I know that this value of A should be equivalent to the same length here between base 1 and base 2, this whole perpendicular line. So this will also be the value of A. Now, I know in a 45, 45, 90 triangle that this leg times the square root of 2 should give me the hypotenuse. So that means that my value here of A will be 3. Because if I have 3 here and 3 here, 3 times the square root of 2 would give me my hypotenuse, and that's what's labeled here as that measurement. So I know now that this would equal 3. And this side also would be 3. And also that this leg, from this point to this point, would be 3. Now they want to know the value of B, which was this entire bottom base of this trapezoid, which is a combination of this 3, and up top, that whole base was 4, which would make this piece 4, so my whole bottom base would be 7. So I utilized my knowledge of 45, 45, 90 triangles and found different pieces and side lengths of this trapezoid. Okay, now also we can do this in combination of two different types of triangles. In this specific example, I have a B, C, and D that I'm trying to find. I have a 45, 45, 90 triangle and a 30, 60, 90 triangle. And I'm trying to figure out my values of A, B, C, and D. If I focus first on this 45, 45, 90 triangle, I know that my A value and my C value should be equal. They should be the same. Now, if I look at my triangle just like the one before, this hypotenuse being 7 times the square root of 2 should show me that A and C should equal 7. Now that I know my value of A, I should be able to use my knowledge of 30, 60, 90 triangles to solve for B and D. Since A is on my short leg, that's represented by X, my hypotenuse is double X. So that means my value of B needs to be double A, which is now 14. The value of D will be my A value times the square root of 3. So I first looked at the 45, 45, 90, found my value for A, and then worked that through my 30, 60, 90 triangle.